Hello, this section is about the continuity. I will introduce the mathematical definition of the continuous function. Computing a limit from section 1.6, we notice that occasionally, or I would say most of the time, in order to get a limit, we simply were plugging the value of a. Of course, the limit as x approaches a. That means we were using the direct substitution theorem. And then if the limit is the same like the value, if the function holds this property, we call this function a continuous function. That means the continuous process is one that takes place gradually, without interruption, without any rapid change. Geometrically, we can think about the curve. We can see the blue curve, that we can draw a curve without removing a pen from the paper. That means without any gaps, breaks, holes, asymptotes. It's nice and smooth curve. And of course, this is a physical phenomena. Physical phenomena are usually continuous process. We may have some discontinuity, and for example, the electric currents involves some discontinuity. Okay, that means now let's look at the definition of the continuous function. That means function f, it's continuous function at the number a, if a, of course, is in the domain. If a is in the domain, most likely we will have a value defined at a, value of the function. And then we have to calculate a limit of the function at a, and the limit must be the existence, must be a finite number. Okay? And now what we're doing, we're comparing a value of the limit and the value of the function. And they have to be the same. Of course, we know the meaning, we understand the concept of limits. That means they're not exactly the same, but from calculation point of view, from arithmetic point of view, they hold the same values. That means if the limit again is the same like the value, which I do have a box here, we can call that function as continuous function at that number. We can also have one-sided continuity. We can say that function f is continuous from the right or from the left. That means let's take a graph x, y, and maybe something like that. And I can say this is my number a, this is value 1, and this is value 2. Okay? That means we can see that the limit as x goes to a of my function f of x from the right hand side, okay, is 2. And value of the function at a, it's also 2. That means we're satisfying a definition of continuity. Limit the same like the value. Of course, only from the right hand side. That means if we're satisfying this condition, we can say that function is continuous from the right hand side, because the limit and the value is the same at that value a. Okay? That means that's how we can define one-sided limit. I know that looking at the graph, we can definitely see a gap. We can see some break. Okay? Some function is like jumping from value 1 to value 2. But, however, we're satisfying this condition. And the same thing, we may have the situation from the left-hand side. I can possibly, if I will change this, but then I have to remove my function, okay? Then I can say that the value is the same like the limit from the left-hand side, and actually, in this case, will be 1. Okay? Then we're satisfying the left-hand side, and function is continuous from the left-hand side. That means please remember about one-sided continuity. Example number 1. Based on this example, we will try to define different situations for discontinuities, different kind of discontinuity. That's me looking at this figure of the graph f of x. Okay. We have a question, at which number the function f is discontinuous? That we have to consider the entire number line. And of course, we have to justify why. Everything what I will do will be based on the definition. That means one more time, remember, definition is limit the same like the value at the given number for continuous function. Okay, that means having this function, I can see some gaps, of course, some changes in the function. I will not draw this function by like one go without lifting the pen. That's what we can see. We can definitely see x equals to 1. We do have a small problem because we have a gap. Okay, we have a hole. X equals to 3 is giving me some, also some discontinuities. X equals to 5 is giving me situation, and 7. Okay, that means I can maybe list all of them. I have to investigate 1, 3, 5, and 7. And we can see it's different situation at different numbers, and let's check. That means what I do have graph. Okay, it's a little bit tiny, but it's the same graph. I just minimize, and x equals to 1. That means what I will do, I will check a limit from the left-hand side, from the right-hand side, and the value. Of course, limit from the left and right will give me a limit, the existence of the limit. That means let's see. Limit from the left, limit from the right-hand side at 1, and the value. That means limit from the left and the right, in this case, is the same. It's 1. We can definitely see it is 1. Value, actually, I can remove it's the open dot. That means value is not defined. Value is not there, which means x equals to 1 is not in the domain. Okay, that means what is my conclusion? My conclusion is that the limit exists because both one-sided limits are the same. Limit exists, but is different than the value. That's we definitely have discontinuity because we're not satisfying our definition. This type of discontinuity we call removable because only one point is removed. That means now if the limit exists and it's different than the value, okay, we will call removable discontinuity. Okay. Value could have different number, not only like non-existence, will be still removable discontinuity. Okay, let's check x equals to 3. That means 3, we have this situation. And what I'm doing, the same thing. Limit from the left, limit from the right, and the value. Limit from the left, we can see is -1. Limit from the left is -1. Limit from the right is 4. Okay, we do have a problem because one-sided limits are different. This means that function doesn't have a limit at 3. Okay, have just 2 different limits on both sides. Okay, we will take this together and make the nice conclusion for the discontinuity. And value, I can see the solid dot. I can see solid dot here at -1. Okay, that means now the conclusion is limit is undefined. We remember that putting D and E, putting this description